So can everyone see the slides? Just do a quick little hand pop up and down just so I can know. Okay, excellent. Okay, I think we're ready to get started. So today we're going to be talking about Altium Concord Pro. We've seen that there's a lot of questions on the forums. We wanted to do just a kind of generic product overview. So that's what we're going to be stepping through today. So we're going to first start off by talking about what Altium Concord Pro is in general, then briefly touching on the key product differences between Nexus, Concord Pro, and Altium 365. Then we're going to do a deeper dive into how Concord Pro is a complete component management system, followed by a product demonstration and a product summary. So throughout the webinar, I will be initiating some polling questions to get to know a little bit more about user needs, just so we can better understand the things that are required for you guys. If you have any questions, please put it in the Q&A section. It's a lot easier to handle them there than through the chat. For the chat section, just if you have something kind of urgent, like you can't see something on the screen, please. We're already getting questions. As always, there are recordings that will be sent out in an email at the end. So let's get started. So Altium Concord Pro is a complete on-site system for component management. It provides up-to-date and standardized component data, as well as bidirectional ECAD-MCAD collaboration, and gives you a method of component traceability that gives you current sourcing information for all of the components defined within the system. This allows you to put everything together in one system without having issues about defining where everything comes from. So one of the main reasons we came about with Concord Pro was we found that when you just ask someone what is a component, we found that depending on the type of job each person is doing, they had a different response. When you talk to an electrical engineer, sometimes they'll just simply state that it's the symbol or a SPICE model, but then when you're talking to someone in procurement, they might just think of it as the supply chain data. So we wanted to find a system where all of the component information could come together and be stored in a way where everyone could access the information they need and be in Concord. So someone just asked, where did the Concord Pro name come from? That's where it came from. We wanted a place where the definition of a component could be in agreement in Concord with each other. So everyone could agree on something. They could agree on the parameter list and the parameter names to define a component. We find that there's a lot of miscommunication between different teams when they're creating a component. Someone might create something and name it resistance, or someone else might name it value. So when we look at the actual issues in library management, we start seeing, as we progress through the different library types throughout the years, we start with file-based libraries like the schematic, PCB, and integrated libraries. And then we move to database and SVN database libraries. Each library kind of brought some new information to the table that helped us organize our component information. However, they still had issues that we felt needed to be overcome. So what are some of the main issues that we felt were not dealt with as a whole between all of these library types? The first being there's a lack of organization for the component structure in itself. All of these libraries are scattered. When you have different individual library files, it's quite possible to have duplicate mismatched content. You see right here, there are two footprints for the exact same component. Two different people, they couldn't find a component. There's no way to actually search for a component. They were unable to know that they already had one, and they went ahead and made another one from scratch. And you could see that there's no revision history between these components. So how are you supposed to know which one you should be using in your design? Which one is more valid than the other? There's no way to tell them apart. So without that type of revision history of the footprint, the symbol, and then the component as a whole, there's not much you can do. You know, when you get to an SVN database library, you have revisioning of the individual symbol and footprint, but the component as a whole doesn't have revisioning. So you lose out on a lot of potential capabilities there. So as I touched base in the last section about the standardized parameter list and naming, when you don't agree upon a naming convention and a standardized list of parameters, it's very difficult to maintain that across all of your components. And on top of that, these library types don't have any built-in unit validation. Therefore, you could put in the wrong type of value in a field. For example, in a field that requires voltage, you could put farads or something that is incorrect. Something that requires a numerical value, you could put letters in. And there's no type of validation in that system. On top of that, there's no association with a real manufacturer part number, which is going to limit your component insights on both on a manufacturer life cycle and availability. So you can't tell if this component you have created is actually available in the real world. And what we've found is that what a lot of people do to overcome this is they just use generic components, symbols, and footprints, which leads to a lot of issues because you do not have any component validation when you do that. And you have a lot of errors. For example, you know, I'm sure a lot of you have seen webinars by Vince Mazer. He just released a blog about a problem he had where he was using generic resistors, and he forgot to change the resistance value from 10K to 100. And he lost out on 500 boards. He was able to work out a deal with his manufacturer where he redid half the boards and the manufacturer redid the other half. But think about that. For a small company that he was running at the time, that could have been catastrophic. He would have had to completely redo all of those. And you know, they're on top of that, with those generic components, it limits the ability to actually reuse those symbols and footprints accurately. Of course, you could reuse them, but then you are opening yourself up to these potential issues, and you have no synchronization between the symbols and the footprints and the actual component that you would like it to utilize. And when you combine it with the lack of association with a real manufacturer part number, you have an even greater issue. So some of the things we identified for Concord was the incorporation of component templates and types. Adding component templates and types allows you to get that standardized lists of parameters and a naming convention for them. You can define that to your needs however you need, but it allows every component of a similar type to have the same basic information. And then you have real world connections to manufacturer part numbers, which then in turn gives you real world connection to supplier part numbers. So you can get alternative part choices pre-set up. So you can prepare for potential shortages before they come up. And lastly, symbol footprint and component revision history allows you to know if you have, for example, an issue with a footprint. Let's say you made a footprint that maybe the pads were too small and you've been having tombstoning. You need to revise that footprint across multiple designs. You're actually able to see which revision of that footprint has been utilized across designs. And there is a where used functionality in Concord Pro where you could see where each component has been utilized and actually navigate through to the project and make those updates. So here, I'm going to initiate the first poll right here. This one's talking about the use of generic components. You know, I just mentioned we've seen the dangers of actually using generic components and schematics. And we find that it's actually still incredibly popular. A lot of people still do this. And a lot of people still have problems. Okay, so this one's a little bit more difficult. This is where a lot of people are having some trouble. So a couple of years ago, we had Altium Vault. That evolved into the Altium Nexus server product line. So the Altium Nexus server product line is now discontinued. From there, your options now, we have updated the Altium Nexus server product into a solution. What do we mean by a turnkey solution? What this means is that the deployment of Altium Nexus is customized to your company needs. You work together with a team to help deploy this system to meet all of your needs. Why is this? Altium Nexus is it's a workflow-driven system, and it has a lot of process management and structures in place to help automate your systems. So it requires a lot of delicate work for actual deployment. So we found a lot of people were actually trying to use the Nexus server without all of this functionality and couldn't get it working properly. So the Altium Nexus solution with the deployment, we talk beforehand on what your company needs are, and then we guarantee the success of that deployment based on those terms. So if process management is really important to you, and you have a team where that type of thing is important, Altium Nexus is a good path for you if you're on Nexus server or on Vault, and you would like to upgrade on that path. If not, Altium Concord Pro is a natural upgrade path. Both of these, you can simply use the installer. The Altium Concord Pro installer will allow you to upgrade with just the installer from Altium Vault and Altium Nexus server. So Wayne here asked me earlier, where do I find instructions of migrating from Vault to Concord Pro? It is not actually a migration. This is the next evolution of the product. So it is a simple update with the installer, and you could do that from Altium Vault or Altium Nexus server. And the last thing I wanted to mention was the Altium 365 platform. I'm sure a lot of you have kind of heard of that. And it's a cloud-based platform for electronics design and development. We're going to be talking more about that throughout the year. I don't want to touch too much on that, but I will say that the very first little view of it, you can see on our website at altium.com/viewer, and you could actually put your design in there and use it as a viewer. I got two questions on this slide. So how is the component management handled by the Nexus solution? So that is still handled by the Nexus server. It's not sold as a standalone product anymore because it is incorporated into the solution. So it's still by Nexus server. It's just not independently sold, right? And someone says, where is Altium Designer in that structure? So Altium Designer works with Altium Concord Pro. So Altium Concord Pro is the component management system that connects directly to Altium Designer, and you will see that as I show in the product demonstration. Okay. Let me click answered on some of these questions so it's a little bit cleared later. I guess in the meantime, I'll ask another question. So we found some people have been asking for a way to kind of outsource their library creation. A lot of people don't have a dedicated librarian or component engineer, so They kind of want an easier way. You'll see in a little bit how you can download information directly from Octopart, but they want a little bit more of a customized experience. So that's kind of what this question's asking about. Someone asked if they update from Vault to Concord Pro, can they use Altium Designer 17? So I believe it requires Altium Designer 19. It might be 19.1, but it requires at least Altium Designer 19. Concord Pro does. And that's because of a lot of the server limitations. So unfortunately, it doesn't work with the older systems. Yeah, thanks, John. John says Altium Designer 19. Okay, now let's keep going. So, on-site component management system. The three major aspects that I want to discuss are the very first one being that the ability to actually search for the components that you have created. We mentioned earlier how you can actually create all these components, but being able to find it was extremely difficult in the old library format. Even if you had a database library, it made it pretty difficult to find the exact component you needed. You are now able to search for any information in the server, any parameter that is in there, any information that has been linked to this component is now searchable. You want to search for the manufacturer part number, you could do that. You want to search for a specific parameter, you can do that, and it's all accessible. There is a convenient component editor which incorporates all of the component information at the same time, which we will go into more detail. And it allows validation of project components by both validating the status of the component and the life cycle of the component. So you can see if a component's obsolete, if it's out of date, and ensure that it is a production level component so that you don't misuse an obsolete or a faulty component in your design. So I'm going to go into details. We're kind of just going to step through the functionality at a high level since this is recorded, and I will put up these slides on the website in time, so you will be able to kind of go through this later and see this in the recording. I won't go into too much detail, but this is the basic the component editor. You can see it preloads information, parametric information that are the basic parameter list and names for any component type, right? And each component has a standardized set of symbols and footprints. Here, and lastly, it has its own area that it is placed in the category and a folder. So it is nicely organized for, it's easy to navigate so that you can find everything and make any edits as necessary in the future. When we talked about component validation, there are a couple different ways of validating your components. These are just some of the high-level checks you can do. I won't go into too much detail. You can go through them yourself. You can check them in your preferences, but these are just a couple of them. From here, we mentioned component status and life cycle. So there are two things. There's the revision state, which is kind of telling you, drop the cap. The revision state is telling you, is this component ready to be used in a design? You can see in this case, this component is in a draft state. So I wouldn't want to release my design to manufacturing with components in a draft state. Why is that? I don't know why it's in a draft state. No one has validated this component. If I don't know if it's actually ready to go. I don't know if someone just kind of made this really quickly. I want to ensure that it is in production state or whatever state you have customized for your own solution before it's ready to be produced. On the other side, on the life cycle, there is manufacturer life cycle information. I know, for example, that if this component is in a revision state, that let's say that's in production, I know that the manufacturer lifecycle is recommended to me as volume production. So this would be a good component to utilize in my design and actually continue through. So when I mentioned alternative part choices earlier, I'm sure a lot of you are familiar with the active BOM system. You can select alternative part choices here. However, when you use the active BOM system, it is on a project-to-project basis. Therefore, it cannot be reutilized across multiple designs. So when you define an alternative part choice in the Concord Pro system, what this is doing is allowing you to plan ahead for sudden supply issue shortages, or for example, just anything that might arise ahead of time. You already know that all of these part choices are valid replacements. And you can see here they are connected both to the manufacturer part cycle, part number, and the supplier part number. So here we actually have potentially over 100 different places we can order from, which is great to have. With a capacitor like this, it's really important to make sure that I have plenty of places I can order from to not derail my product manufacturing. And on top of that, if you really, once you do that, you can use the active BOM system to actually rank those alternatives and designate desired replacements at the production volume that you want. So when we talk about component searching, there's a lot of powerful information you can use in the new components panel. So the components panel was introduced in Altium Designer 19. A lot of the functionality, though, is really integrated with a managed server. So you need a server like Concord Pro or Altium Nexus, or in the future Altium 365. You need to be able to have all of this parametric information stored somewhere. With that, you're able to filter first by component categories. Then you can use filters that are all searchable. So you can search for the information, both of the filter name and the information within the filter. So if I want to look for a specific value in the filter, I can do that. You can see that there are ranges in the values. And once I have found potential components, I can actually compare them and see similar and dissimilar parameters. Dissimilar parameters being in red and similar parameters being in white. So I can make comparisons very quickly, including seeing symbols and footprints. And I can make a placement decision in seconds and actually just drag and drop it onto my schematic very quickly. With that, actually being able to download models and parameters. So the manufacturer part search panel is a basic part of Altium Designer. However, incorporating the Concord Pro system allows you to acquire the information directly into the system. What does this do? It pulls in the manufacturer part number information, the supplier part number information. If it has this little green symbol next to it, the little green component, that means it has models already. So you can have a symbol and footprint from the get-go. And you can also bring all that in and modify it. So for example, let's say I want the majority of the information, but I want to use my own symbol and footprint. I can do that as well. And I can continue forward, and you can make a component in very little amount of time, and you'll see that in a little bit. You have the ability to update and replace components with literally the click of a button. I hate being hyperbolic, but that's like an actual thing you could do. You can just click update and it will update. I really love this. You're able to see anything that needs to be updated. If you're on your schematic, you can use the properties panel, and you could click the little dots next to the component, the item ID, and you could find a replacement, make a comparison. And as I mentioned earlier with the where used, I can look at replacements and actually see where they've been utilized in other components. So I might identify that there's actually a replacement for a component that has been utilized in a lot of different designs, and maybe that's a better choice because I can now make a bulk purchase order, and that might be better for me. You know, this example project that is included, the Kame board, it's a drone, it's a multi-board drone project. It would be ideal to have a capacitor utilized across all of the designs, the same capacitor. So you get a lot of really important information there. When we talked about verifying component status, ActiveBOM is the main tool to do that. You are also able to compile your schematic and use, you can output a component states file that will give you that information as well for the end of your process when you're ready to release to manufacturing. So you have a way to check throughout the entire process the status of all of this information, so to make sure that everything is up to date. So you get the manufacturer lifecycle information, and you have the revision state and status throughout that design. Last thing I wanted to talk about before we get to the actual presentation, the demo, is the ECAD-MCAD co-design. So this allows bidirectional design collaboration directly from within Altium Designer. You're able to pull and push changes, and what's really cool about this is that you're able to comment on these changes, which gives you a level of traceability. It shows you who made this change at what time, and with the commenting why, right? And you're able to configure the collaboration options to get a little bit more information about all of this. And currently, we work with SolidWorks, PTC Creo, and Autodesk Inventor. With SolidWorks, there is, you need to talk to them and work with the SolidWorks PCB connector. There's an additional license on their side of things. For Creo and Inventor, that is not the case. But just, you know, just so you are aware of that. So now I'm going to switch over to the product. Let's see, new share. Okay, can everyone see that? We good? Can I get some hands up real quick? Yeah, okay, good. So we're gonna get started over here. We have a design here. So the first thing I'm going to show is actually compiling my design. So when I compiled my design, I'm able to see I have a component revision out of date, which is identified quickly there, and I can actually navigate over to it. When I click on it, I can quickly see that the component is out of date. If I want, I can go in to replace it if I would like. You know, I can look at why it's out of date, and maybe the best idea for me is to replace it, you know, maybe make a comparison between the two, and select that replacement. I actually need this later in my design to demonstrate other parts, so I'm not going to make a replacement, but I just wanted to show that option. I could also do the update, so I'm going to update, and it's actually going to pull all the information. You see it's the latest revision, new revision, and it will pull in all the new parameters, any information that was updated. Like I said, I need this later, so I'm going to undo that actually. You see it's now back out of date. But you can see that in a matter of seconds, I would be able to update any part of my design. And then through, you know, while you're in the middle of the schematic process, it's good to use the system like this. Generally, it's best to use Active Bomb because you're able to see the full list and do a batch update of all of these, which I will show in a bit. Okay, so from here, let's go to the components panel. So we're going to start off by going through the categories. So when you click here, you can see all of the categories I have defined here. And if you have any temporary libraries for like work in progress while you're working on your design, you can see them down here. Okay, so power supply. And I'm going to open up the filters. And you can see that I can actually search for different things. So I'm going to search for output voltage. And I want something between 0 and 4 volts. So that will be my first filter from there. Secondly, I'm going to look at the current. And I'm going to set it to 1 amp. And you can see here, I have starred this. What does that mean? It means that this is one of my favorite filter parameters, so it will be up at the top of the list. So it makes it easier for when I'm looking for components. Maybe those are fields I often search for so that they're already at the top and I don't have to search for them. But I just wanted to be able to show you how easy it is to actually search for something. And if you want, you could put like 1.3 amps, right? And it actually shows you that information. So every single thing that is put in here can now be shown. Okay, so I get the 2. I do a comparison, and it shows me all of the dissimilar information in red, similar information in white. As I come down here, I actually see that this one has more footprints, and this is my default footprint, meaning anytime I place this component, this will be the footprint that is utilized on the PCB. So I like the fact that there are multiple options. So I'm going to place that one. You can see it's as simple as dragging and dropping it. So I'm going to clear my filters, and I'm going to come back to the top. I mentioned earlier that you can search for manufacturer part numbers. So STM32, you can see right here, I started searching and I can find it right here. It's as simple as that. And I can still do the comparisons as much as I want. So what about for components that you don't actually already have in your system? So let's see. What if I want something very specific? So you can see here, I'm looking for this, and I don't actually have this. So I have 2 options. It says, would you like to try the manufacturer part search panel and search for that, or would you like to start trying to create a component? I'm actually going to see if there's any information I can pull from the manufacturer part search panel. So I'm going to open that. I'm going to initiate a poll right now. This one is about sending your library with your design to manufacturing. Okay, so you can see here, I have a lot of different options. We have information here such as the manufacturer lifecycle. I am going to try and stick with some green ones because that would imply that there's a higher likelihood that that is a good choice. This already has some models. I have 25 suppliers that are associated with this manufacturer part number. That sounds pretty good. So I'm going to right click and acquire. From there, it's going to ask me the component type so that it can place it in the appropriate category. So I do capacitors, and it instantly starts loading all of the parametric information from that template. And then it asks me, do you want the information we have already? So I say, yes, I would like to use all that data. And it's going to pull in all of this from the Octopart system. And I will have a lot of rich parametric information without having to do much. So you can see here, everything's already filled out basically. I have all this, all my basic parameters for my template have been met. I can add links, data sheets, parameters here. I could add more part choices if I would like here. I have all of my models. I can set the default as I would like. So I'm going to set this one as default. And you can see that now this is my default. When I place this component, this is now my footprint that will show up by default. And I can change them as need be. I could add more footprint simulation models as necessary. I could remove these, or I can change them if I have my own symbols and footprints that I would like to use. From there, I can just do file, release to server, and it will do a component validation check. So it found two issues. It's asking me for comments. I'm just going to release it. So what are the issues it found? It found that it couldn't find a revision status for that. That is an issue because those have not been released yet, so those are fine with me. That's why I released it. And you could see in a matter of 1 minute, I released that component and it is ready to be used. If I go back to the components panel, and I refresh, .22 microfarads. There we go. Ready to use in my design in under a minute. And I mean, that was pretty easy. I didn't have to do much. I just found all the information I needed and was ready to go. The good thing is, so it's now in a draft state. It's ready to use as like a popcorn resistor. It is in a state that is akin to a generic component with a bunch of existing information that I can update in the future, right? It's now in a draft state. So when I'm ready to use it in a design, someone will go validate it and put it in an in production state, right? So you get the benefits like you would of a popcorn / generic component without the downside of potentially mislabeling something, putting the wrong parameter, forgetting to change 10K to 100 and having 500 boards that don't work, right? So it's a very powerful addition that I think is pretty great to have. If you come over to the active BOM document, it's going to update a little bit since I just placed a couple components. You can see right here, it's updated. I'm coming through here and you can see, I'm going to have to refresh this. I'm going to start another poll. This is the last poll. This one is talking about the approximate size of your combined component library. So just the unique components total across all of your libraries, resistors, capacitors, etc. We find there's actually a pretty significant range between, different companies. Okay. So, I've been switching in between my my different servers. Okay, so we're gonna go over here. We're gonna skip the active bomb part for a second. We're gonna come to the MCAD side, or the MCAD code designer. So you can see here a bunch of different changes that have been pushed through. So we have my design here in 3D. We can see what it looks like in the Altium Designer environment. And it looks pretty good. I now want to see what it looks like in SolidWorks. Okay, so you see the same board here in SolidWorks. Give me 1 second. Oh. Okay. So from here, you can open the code designer, and I can make an edit. So I come over here to move component, and you know, I feel like this edge connector's up a little bit high, so I'm actually going to move it down a little bit. I'm going to select. You know, what's really nice too is that you actually have the full copper export here. So you're actually able to run simulations in this environment from the mechanical side, and you can disable the copper export if you want to speed up the transfer a little bit. The first time could be a little bit slower as it does all of the copper the first time. The subsequent times it's doing the changes as opposed to the whole board, so it's a lot faster. But if you would like it to be a little bit faster, you could disable that in the settings over here. So now that that's done, I'm going to push this, and I'm going to say moved edge connector. Oh. Moved edge connector. I'm going to post that. Okay, can everyone see Altium Designer now? Good, okay. So we come back to Altium Designer. We have the design here in 3D, view changes. It starts detecting the changes and processing the board data, and I'm actually able to click on it, and it will show me the movement that has been processed, and I am able to select the changes and apply the changes. You see here some grayed out information. That grayed out information pertains to things such as plated through holes that exist in the environment inside Altium Designer that don't have a good way to be modeled within SolidWorks. Oh no. The screen sharing wasn't working, was it? Now it's working, right? Okay. I'm taking the hands as yes, it's working. Well, I accepted the changes. I guess I can move it again. I'm gonna come back here. I'm gonna move it back. Okay. Push. Move the connector back. I'm in SolidWorks right now, so I'm switching back. Okay. View changes. Here we go. As you can see, hopefully, it shows you the movement of the component. And then I can now accept this change and apply it. And there we go. What I really like to be able to do is the fact that if I, for example, move all of these components and the polygon pore changes, it will bring those changes all over to the mechanical side, so you can have all that copper information in there. And I think that's really powerful. Heading back over to ActiveBOM, I mentioned the revision states. You're able to see here, this component is out of date. It's the one I showed earlier. You can update it to the latest revision here. This is why I mentioned it's good to do it in ActiveBOM. Let's say all of these are out of date. I could right click and update all of them, right? Which is, you could update multiple at the same time, which is good. So I'll update that one to the latest revision. And then we also see some things like, for example, this one's not recommended for new designs. So if I come down and I look, I see that this part choice is not recommended for new design, but this one is deemed a new product. So if I simply rank that one higher, I can see that that's a better supplier for me, and I am ready to go and produce my design. So that is everything on that side of things. And okay, those are the slides. Everyone can see the slides? Yes? Okay. So our goal with Concord Pro was to create one environment for everyone to be able to communicate and be in Concord. You know, like we said, be in agreement on everything, and be able to communicate all of the information that is relevant to them for a component management. We wanted it to be as simple as possible to actually be able to use components and designs and actually update things without it being a complete hassle. You know, so we wanted to create a place where everything could live together and be in agreement. So, you know, it's a single component storage location that gives you component editing with these parameter templates. You have standardized component categories, external and internal component statuses, as well as validation and verification of every single component with alternative components in place to help prevent any potential errors, and bidirectional data exchange with MCAD environments to ensure that you can utilize that rich parametric component data and the models to their full extent to ensure perfect assembly fits for your product. So the last thing I wanted to say was, if you want to start an evaluation of Altium Designer 19 or an evaluation of Altium Concord Pro, you can go ahead and go to our website for that. You can sign up for webinars at altium.com/webinars. I know we have some promotions going on right now, so feel free to call your account manager if you're interested in learning a little bit more about that. I believe we're finishing up a data sheet for Concord Pro if you want a little bit more information about specific details. That's the basic aspect of everything. I just want to thank everyone for their time. I'm going to open it up to questions. I'm starting this new thing called office hours that we're going to try and grow out. This will be the first part we do, and I'm just going to open it up for questions. I see we already have 27 questions, so we're ready to go. Okay, the first question is how to name components. With this system, you know, we recommend just going